Yeah, you're welcome to my Graham's Law of Diffusion class. Graham's Law of Diffusion. Okay, Graham's Law, of course, is a name of someone, Graham. The law of diffusion. You know diffusion in biology or in physics, that the movement of particle from a region of higher concentration to a region of lower what? Concentration. And then we are talking about Graham's law here of diffusion. What does the law state? The law states that the rate of diffusion of gas is inversely proportional to its density. Okay, or you could say that it is inversely proportional to its molecular weight. So either this or this, but we use the first one and we relate it with this. Okay, so this is what you have. It says that the rate of diffusion of gas is inversely proportional to its molecular mass as well. Now, it therefore means that there's a relationship with diffusion molecular mass as there is. Let's look at something quickly. Suppose you have hydrogen sulfide, you have sulfur oxide, you have ammonia, you have CO, carbon monoxide or carbon dioxide, and all of these are there, and you are asked to find, and then you are asked to arrange in order of decreasing or increasing diffusion. Okay, that's what you are told, either to increase or decrease. Now, you don't need to bother yourself so much. What you need to do is to calculate the molecular weight. Calculate the molecular weight. If you can calculate the molecular weight, then you can tell. The molecular weight of this one, for example, is 17 grams per mole. You know, hydrogen is 1 times 2, that's 2. Yeah, sulfur. No, this is 34. Sorry. This is 34. Sulfur is 32, and then this is 2. Yes, sulfur is 32. Oxygen is 16 times 2. That's 32. That's 64 grams per mole. And then come to ammonia. Nitrogen is 14. Hydrogen is 1 times 3. So you have 17 grams per mole. And then this is 12. And this is 16. That is 28 grams per mole. Obviously, sulfur oxide has the highest molecular weight. And so it's going to be the slowest. The more the molecular weight, okay, the slower the rate of diffusion. So they are inversely proportional. The more the rate of diffusion, that means the lower the molecular weight. So it means that ammonia will diffuse the fastest, followed by carbon monoxide, followed by which one now? Followed by hydrogen sulfide, and then you have the last one, sulfur oxide. So please take note of that. So let's continue now as we come to this place. So we have this is equals to this molecular weight. You introduce your constant. So your constant equals to this. Then you have this. You could also have it this way, so that you have K, R, and then your vapor density. Now it should be noted that our molecular weight, which I'm using as a capital M, is our 2 density. So in other words, density is molecular weight divided by 2. So that is very important. So if the molecular weight, for example, now the molecular weight of sulfur oxide is 64, what's going to be the density from this calculation? You can see now that the density is going to be 32 as you divide it. So that's what we're saying. Okay, so now with what I have here, so if the rate of diffusion is inversely proportional to either the density or the molecular weight, I can then say that R1 and R2 is equals to what? The density of this, no, 2, sorry, and 1, because they are inversely proportional. Or you can say that this is equals to 2, 1, and then this is 1, right? Yes, we can say that. We know that rate is also directly proportional to volume. So what that means is that R1 over R2 is equals to V1 over what? Over V2. We know that rate again is inversely proportional to time. What that means is that you have R1 over R2 is equals to T2 over what? Over T1. Now, marrying all these together, how will you now have it? If you are to marry everything together, it therefore means that R1 over R2 is equals to what? Your V1, look at it, over what? V2. Let me marry these two. That's T2 over T1 equals to what? Molecular weight 2 over molecular weight what? No, density, sorry. And then molecular weight 2 over molecular weight what? 1. So this is the entire formula you can have. Yes, so when you are given question, you should know the one that comes first and you should know the one that comes second. You should know how to do your proper substitution. And so this is the summary of Graham's law of diffusion. You can employ this formula to solve any question. Bye.